Hello, everyone. How are you doing? Fine? I assume that is good. Good lunch. My name is Eduardo Silva. I'm a principal engineer at ARM. And as you know, we are in the deep dive session of Fluentd project. And this deep dive session will focus on the Fluent Bit project, which is a sub-project of the Fluentd ecosystem. As I said, I'm an engineer at ARM. We used to be Treasure Data, the company who created Fluentd. And I'm a maintainer of this project, which is called Fluent Bit. First of all, do we have any Fluent Bit users here? Please raise your hand. Oh, that's good. So I think I will owe you some stickers, T-shirts, and stuff. Well, we will cover something that is really new here. It's called stream processing. But before jumping to that, we're going to get to the basics of logging. When an application generates a message, that message is composed as a record. That's like the technical term internally, either in Fluentd or in Fluent Bit. And that record is not just a message. It also comes with some metadata. And that metadata means the timestamp of when this message was created, plus the same message that now is going to be serialized. You can imagine, for example, a JSON map, but on this case, we use message pack. JSON is like a human-readable format, but message pack is binary. So you can think about the performance that you have working with JSON internally, inside Fluent Bit or Fluentd, versus message pack. So an application generates a message. That message becomes a log. That log goes to the file system, maybe over the network. And in the other side, we have Fluent Bit generating a record with this information. That becomes a binary record. Then inside, in the internal part, the records can become our group, right? For example, if you are consuming logs from an input section, and this input section means a couple of log files, maybe these log files has many information, and you want to group them by tags. So you're saying all of these messages are coming from Apache, or all of these other messages are coming from syslog. And why grouping them is really important when you want to do logging stuff, because you need to sort and have some order for these logs. Because your end, as we said in the keynote yesterday, is not logging. Logging, as I said many times, is boring. But what you want to do in reality is data analysis for troubleshooting, learning, or whatever. Once the data or the records go to the storage phase, this can be either in memory or the file system. It goes to the router. The router basically said, where are these records going to be delivered? And as you can see, you can define multiple output plugins or configurations output from where you would like to ship these logs out. And where you're going to ship it can be your Elasticsearch database, your cloud service, or whatever. And if you look carefully, the router does a really special job here because it matches the tag from each record with the match section defined in the configuration. So the router say, OK, all this bunch of records have this tag. I'm going to look for the matching rules, so this data is going to this place. Or maybe that same data is going to multiple places. That can be done too without any problem. In the Kubernetes space, it's like this. I'm sure that most of you are using Kubernetes or are familiar with Docker. But in Kubernetes, we have the concept of the master API server and the node. In a cluster, we have many nodes, right? But if you have applications deployed in a node, you need to have your logging processor to be able to consume the logging information from the other pods or containers. So what we do is that we deploy Fluent Bit or Fluentd, it doesn't matter what is the case. We mount the volume of the node logs, and then we let the log processor consume those logs. Now, how this correlate with the main topic of this session, which is called stream processing. Are you familiar with Apache Spark or Kafka KSQL? OK. So with Fluent Bit 1.1 release, we focused on two major things. One was Windows support. You can realize that many Windows servers running. And many people has been asking for Windows support. Maybe people is not really interested to do a huge processing in Windows environments, but they want to take out the logs out of the box to a Unix box for processing, aggregation, or whatever. So we have Windows support in beta. So if you're a Windows user, you're administrating Windows services, please build Fluent Bit. It's in a beta phase, so any feedback you can provide us is really important. And the second part is stream processing. So what is stream processing? Who can describe stream processing? Please raise your hand. Let's try to make it more friendly. It doesn't matter if you're wrong or you're right. Maybe I'm wrong. But what means for you stream processing? Lady. Oh, microphone.
It means I want to transform my data as it is flowing through my pipeline.
Yes, transform the data as far as I get it into my pipeline. Perfect. So this is not just streams of data. So a stream of data can be anything. But stream processing is the ability to transform the data while the data is still in motion. Okay? So if you're going to process data in your database, your data already was collected, processed, aggregated, indexed in the database, and then you're doing queries. But here, we are talking about do stream processing on the edge side. Who of you are using Elasticsearch? Please raise your hand. OK, so all of you are using Elasticsearch, not just to use Kibana, have fancy dashboards, right? You're using it because you need to index your data, you need to query your data. But I'm sure that at some point, most of you are not quite happy with the performance of the results, so the performance of your results. And not because of Elasticsearch, because indexing is expensive, right? You need to get the data, go to the database, the kernel cache, flush, blah, 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 blah. And sometimes you need to get a feedback loop faster than indexing. So stream processing on the edge, it's an ability to have data selection, filtering by patterns, perform data aggregation. OK, this sounds familiar because Fluentd and Fluent Bit are already kind of doing that. Or maybe this is kind of new, create new streams of data based on query results. Maybe this sounds familiar to people who ingest data into Kafka, into a half storage, then pull this data with another log processor and create a new stream based on results. But here we are talking about a Java stack, right? If we talk about Elasticsearch, you need Java. If you talk about Kafka, it's Java. So sometimes we need something more lightweight and something that can provide us data as soon as possible as something is happening. Imagine that you have your cluster, and maybe you're reading credit card transactions, and somebody paid for some item twice. How do you detect that in 2 seconds? Can you do it with Elasticsearch? No. Maybe in two seconds after the indexing took 10 minutes, right? But that is not ideal. And the point of this talk is not to blame any database, because that's not the point, but the point that indexing takes time. Indexing is expensive. We cannot get rid of indexing because we need it. But also we can improve how do we operate and create queries. So all of this is about performance. Performance in technical terms, in computing time, performance in networking, bandwidth, and also performance in how fast do I get my data back. And in logging in general, we have many pains. Okay? Accessing the file system is expensive. It doesn't matter what kind of storage you have. Perform data parsing is even more expensive. We are not dealing with binary data. Usually, if you have a JSON map or a JSON log, that is really expensive to parse. Okay? It's not magic. It's expensive because you need your parser to go byte by byte, checking, oh, this is a map, this is an array, did it end it, did it not? Maybe you have a stack to try to check if this is a valid or not. And then you have your database indexing. So expensive, expensive, plus times expensive. And then you have your data. Okay? So we work on this area, on Fluentd and Fluent Bit. We are flexible, we are really fast, both can integrate each other, or we can work as a standalone solutions. And that's perfect. But what can we do in the other scenario to help to reduce the load on the database for some queries that maybe we can do on this side, on the edge? So we're going to do a really quick demo. Basically, I have 1 million records in just one log file. It's a 100 megabytes file, but anyways, it's expensive. And every line is in JSON format, and I'm going to process the data and index it in a database. Please guess how much time it will take. Raise your hand. Speak. Milliseconds? 1 second. 1 second. OK, but we have file system, parsing, indexing. 1 second. OK. Can you see the screen right? OK. I'm going to stop the database, restart it, cleaning up everything. As I said many times, don't do this at home. The delete command is really dangerous. Plus with all. OK, I just wiped the database. OK, I'm using curl command line to query Elasticsearch. I'm not going to use Kibana because this point doesn't make sense. OK, so where's my file? My file is called KubeCon sp.log. Maybe we can do something like this. Oh, well, I'm going to break it. So every record has like this: a date, an IP address, a word, and a country name, a flag, and a number between 1 and 100. So it's nothing complex. If you can realize the record is quite small. So what I'm going to do is to process this log file with Fluent Bit, and I'm going to send it to Elasticsearch. So, and please try to come up with, to realize how much time that could take. So here, I'm going to query the Elasticsearch database, the indexes. Some people are smiling because they know that it will fail, right? In this. Something like this, if I'm right. Oh. Can you read that? OK. What we care about is the number of documents that we have in the database. We have nothing now. I'm going to my Fluent Bit configuration. I'm going to delete that, did some cleanup. OK, this is a setup friendly for Elasticsearch. OK. I'm going to do something. I'm going to be a really bad logging tool that is going to process the data really fast and send that very fast to the database, right? No limits. And here, I'm going to send the data to Elasticsearch for all records in log-stash format. OK. I think that that should be enough. We're going to run Fluent Bit from the command line. OK. So we see that the number of documents is increasing. You are counting, right? 1, 2, 3, 4, 5. We have 1 million. OK, so something happened here. The numbers are not growing because our file has 1 million. So we sent a 4,000, and it's stuck. So what's going on here? Let's try to reach database. Oops, I don't get a response from the database. I'm running localhost, right? But I'm not doing anything like crazy. Oh, here in Fluent Bit, I got my connection rejected. That's why when we get a ticket in GitHub say, hey, my data is lost, I cannot flush the data. OK. We need to do some troubleshooting, but here I'm not able to connect. Wait, where's my Elasticsearch? It crashed. And we sent how many records? 5,000. So in the cloud space, tuning and buffering is everything. I'm not saying that Elasticsearch is bad. I'm saying that if you send just a little bit of load, you can crash things. Well, but our goal in this talk is not to crash the things, right? So we're going to properly stop Elasticsearch, and we're going to start it again. I'm going to stop Fluent Bit, so it will stop sending data. And I'm going to wipe the database again. How much data it indexed? Oh, 23,000. Not too bad. I'm going to delete everything. OK, database is empty. Now we are going to be a good citizen. We're going to apply this, which is called memory buffer limit. So we got a problem that when we send a log processor, Fluentd and Fluent Bit send data too fast. But that is not the problem. The problem is that sometimes database cannot process all the data. So what we do is that we put some limit and said, I'm going to take data, process this data in memory. I'm going to have 10 megabytes, try to ingest this data, but I'm not going to consume more data until these 10 megabytes are flushed. So with this, we provide some kind of workaround for the database to process and index the data. OK? So let's run it again. OK, we're doing better. As you can see in this number, here, the number of documents is going up. What we did is just to put some limit, some kind of threshold in the Fluent Bit to send the data more slowly. Well, not slowly. But again, we send 1 million, and we are having like 10 seconds, 15 seconds, and so on. And we have not done any query, just indexing. So I think that you got my point, OK? So if you're going to move data, you need to prepare for failures. And also, we can improve on many areas. So let's finish. Say 800,000. It should reach 1 million so shortly. There you go, 1 million. Cool. It took like a minute or so. Just one connection. OK. So how much time did it take? 1 minute or more. So here we have some challenges. Why I'm caring too much about data indexing? Data indexing allows you to query your data faster. That's the whole goal. But if you want to query your data and indexing is becoming a blocker for you, we need to think in something different. And that is Fluent Bit with stream processing capabilities. We was released just last week. What you can see there is the login pipeline. So what we did is like after the input side where we collect the data, we parse the data, filter, we have the storage side. Before to route the data out, what we do, we put a new engine from a stream processor. And the stream processor can do a lot of queries. And this is really good, because we do it with SQL, structured query language. So SQL used to be boring, but nowadays I think that it's quite fun. But you say, but what? Did you put any database on Fluent Bit or so? No, there's no database, because this is stream processing. Everything is happening in memory. There's no tables. There's no concept of indexing. So for Fluent Bit, every input plugin is a stream of data. And we can also do data aggregation. So let's do a second test. I have the same file, but I just want to retrieve the fields called IP, country, and num, which are the JSON keys. but with the conditions where the field num is greater than 80 and the field country equals to Chile. So if I want to do that with a database, it will take a minute or more, with a very low load. But how can I accomplish this same thing, but with Fluent Bit? So here you have a really simple SQL query. Select IP country num from the stream, KubeCon, because in the configuration I call all my data that comes from the KubeCon sample files is called KubeCon. So there's no table notion. My table becomes my stream of data, where num greater than 80 and country equals to Chile. And this is a stream file, and this stream file needs to be configured here. Stream.conf. And we're going to do something here. Let me check something. OK. Right now, we are not going to ship the data to a database, just to the standard output, but from the engine. So I'm going to modify my output to null. And I'm going to increase my buffers for reading, because I want to become faster. We don't need is not. So there you go. So you start getting the data right out of the box in your terminal. Well, that is useful for debugging purposes, right? You cannot do anything with that. But you already got what you wanted. Well, it got all the records, so it queried the 1 million in just a fraction of seconds. That is what we are trying to achieve with the stream processing on the edge. Reduce the number of CPU that you have to invest in your cloud side, but defer it to the edge. The edge can be your Kubernetes node, can be your Raspberry Pi, your IoT device, or anything that is running Fluent Bit. OK, do you think that this is good? Yeah, cool. Now let's do something better. These results were sent to the standard output. But now, what we're going to do is create a new stream of data in Fluent Bit using the results of the stream processor. Are you familiar with KSQL of Kafka? Some of you? Well, so we will do create stream KubeCon as. So the new stream of data will be called KubeCon, and all the data on that stream will come from the output of the query. But we're going to do something better. With, do you know that we talk about tagging, matching, and routing? Tag equals results. So all the results from that query will be created as a new stream with a tag called results. Go to my Fluent Bit configuration. I'm going to send the data where? Elasticsearch. Match everything, but we're going to match only results, because we care just about the data that we just processed. We don't care about the others. And yeah, we're going to use the non-friendly setup. Maybe it works, maybe not, I don't know. So are we good now? It should work. OK. Let's wipe our preferred database. Uh-oh, I had to change my stream name. So the stream KubeCon already exists, because in my configuration, I put an alias KubeCon. OK? So that's why I got an error. KubeCon, cool. No, KubeCon does too. That is normal. That happens every day. So, OK, let's give it a try. So it will take the same amount of time to to ingest the data in the standard output, but to Elasticsearch. So here, we're just getting the final results, and it ended up on 60,000, because that's a result of our query. We don't get to 1 second, as the lady wanted, right? But we did it in 3 or 5 seconds. So with this approach, we can extend to many possibilities. Do you use MySQL, PostgreSQL from the command line? One of the things that we are, well, our thoughts is, OK, how we can implement some client-server model on this? Imagine that you're running your cluster, your nodes, and you don't know what's happening with your data on certain node for some type pod or some type container. Imagine that you can connect remotely to Fluent Bit directly to the stream processor, create your query, and get your data remotely. You are skipping the database, you're skipping everything. So the possibilities here are many. Even we are considering to have some kind of storage, not behave like a full database, but something that can provide more reliability for queries that need to run for a long time. OK, so this is just one of the use cases, but there are other use cases. Do you know the concept of data aggregation? For example, you have a table of data in your relational database, and you want to get an average value of certain fields that has some matching criteria and so on. Let me show this. I'm going to split the configuration here. We're going to prove this. For example, just so you can get a notion of what's going on here. OK, who can explain this query? Average? OK. Exactly. We're going to select. OK, we're going to explain in a different way. We're going to create a window of time that means every 20 seconds, calculate and get me the whole records that the country is Chile, and group by country, but calculate the average number of all of them. Where this use case is useful? IoT, embedded gateways. If you have a bunch of sensors, do you want to send thousands of records to the cloud to calculate something? What's the average temperature at home in the last week? No. Maybe you can do the calculation on the edge and just send out the results, pretty much as we did with Elasticsearch some minutes ago. So I'm going to, did I save it? No? Oh, cool. Yeah, we're going to fix this because in the configuration, Fluent Bit is very strict. Every value is just one line, but I think that with this use case is painful. But anyway, so our stream here is called results. It used to be KubeCon.2 with the tag results. OK. And we are going to change the aggregation file. For simplicity, I put the string files, so the string queries in separate files. But you can have many tasks. And it's something that I don't have time to show here. But what you can do also is create a new query based on the results of the previous task, the previous query. Because every stream that you query, you create a new one. So you can do some kind of chaining between them. So aggregation, and we're going to put the results in the standard output, just to get a notion about how it works. This is not necessary. Aggregation. OK. So we have to wait 20 seconds, right? Because it has a window of 20 seconds waiting for data to be processed. Tick, tack, tick, tack. I should have put 10, right? Where? There we go. So we got the record output aggregated, and the average number between 20 seconds, we got 1 million records. So we processed all of them. We look it up for Chile. We did some aggregation window, and the average number is 50 for all of them. So these kind of things are very flexible. What kind of features are missing at the moment? For example, join streams. If you have multiple streams, maybe you want to do some query with a join between them, pretty much as you do with a table in a relational database. And well, that was all about stream processing. And if you have questions, please raise your hand. I'm happy to answer all if I can. Oh, one announcement. We have some T-shirts here. So before you leave, please pick them. And we have a ladies size too. So if you want, please feel free to wear your Fluentd T-shirt.
Hi.
Sure.
So inside this query you just showed us, there's this time window. Sometimes you want to backfill, for example, log files. Can I access there the timestamp value and say, OK, group by the timestamp value? Because now Fluent Bit was waiting 20 real-time seconds, but I want to have 20-second slices maybe of the timestamp. Is that possible?
20 seconds. So it's like to query the timestamp? Or?
Yeah, usually you have your logs in a chronological order with a timestamp, but maybe you want to backfill it sometime later. So you want to parse the timestamp from a log file, for example, and then say, OK, group it by this 20-second slices that was already recorded maybe even years ago.
Oh, OK. So you want to have Hadoop in Fluent Bit. And you know what? I'm going to be honest. We are taking the best ideas of what is in the market and what are the needs. Because what you just said is in between Apache Spark with Kafka. Right? Yeah, because right now, everything is happening in memory. But I think that will not be hard to add some kind of storage, like Kafka, because it's like append log with timestamp where we can do that.
Actually, you wouldn't need any more than this. This would really just still be stream processing. But instead of waiting for this 20 real-time seconds, see, OK, how much, or get the notion of time from the stream of timestamps.
Ah, OK. So get some insights from the timestamp to perform the queries. Interesting. Yeah, I never thought about that. OK, we'll take into account.
I haven't been working with Fluent Bit for a while because one feature that I had been missing was tag rewrite. This looks like it solves it, doesn't it?
Sorry, I didn't get it.
So I can use the stream processing to rewrite my tags from my input sources.
To rewrite your regex?
The tags.
The text?
Yes.
Happen that stream processing can be done because we already do the conversion from unstructured data to structured, because we parse the data. So we have a binary map. So we know the fields that we have on every record.
Yes.
OK? So you can do whatever you want in terms of query on top of this. All is possible. Right now, we are extending the language. Not the language, but the support of SQL. Because right now, support very basic stuff, comparison, aggregation, windows, count, sum, minimum. But it can be expanded.
It looks super powerful.
Yeah, and actually, to be honest, I would like to, because you are the users. So if you can go to our GitHub repository, create a new issue like SP, which is the short term for stream processor, like we need this, that would be really helpful. Because we don't know all the use case that you have.
Thank you.
You're welcome.
Thanks. I'm just curious if you support multiple levels and depth in JSON, or it must be a flat, like a JSON map.
OK, the question is, if you want to query, show me all the records that Kubernetes labels app or color equals blue.
Employee.age or something like that.
Something like, for example, like this.
Yeah, maybe.
I don't know.
Yeah, so can you address that in your CQL?
Not yet. We are going to implement that, which means to query the sub. Well, this is like a arrays, right?
Okay.
And we are with binary data. Yeah, we're going to expand that for the next version.
All right, thanks. The other, just note that in Lua script filters, you can do stuff like
yeah.
what you want.
And actually, talking about Lua, you know that in SQL you have this kind of concept. Well, in databases, store procedures, and you have these user-defined functions. So we're going to implement that so you can create your own functions for the stream processor using the Lua scripting. He wants to have a question. For now, excuse me, for the question, you can take a note of the address for the stream processor guide, which is like a separate document, and there's a little hands-on about how to get started, please.
So in this new world of microservices and lots of containers, lots of pods and everything, we're talking about lots and lots of data. Would you recommend running Fluent Bit, for example, as a sidecar container, running near the pod? That would be one log producer. But if I'm interested, for example, if I'm having stable services, they do the same job, they deliver the same data, I'm interested of summing the averages of CPU or whatever from all these sources. Would you recommend putting a Fluent Bit aggregator before of the sync? Because we are currently facing exactly this problem. We are syncing into Elasticsearch and there's a huge amount of data, and we are going to move into, to put a Fluent aggregator before of it, but that's Fluent, traditional Fluent, not Fluent Bit. So
yeah. So how to optimize and where to put the data collector for aggregation? In general, I think that sadly the answer is always the same that we have. It depends on the use case based on data, how much data you're generating, what kind of data, and what's your load overall in your cluster. Because some people said it's configuring, for example, when talking Fluent Bit to Elasticsearch, what they are doing is putting a memory buffer limit of 50 kilobytes. Pay attention, 50 kilobytes per node. But happens that there are clusters that had 200 nodes, 300 nodes. And sometimes that is too much load for Elastic. So I would say that just give it a try, with as a sidecar, as a daemon set. And there's not like a magic rule for that, because as you know, data processors or logging tools, we are really fast. But that can mess up your environment because database or whatever is not so fast, or your network doesn't have enough bandwidth. So I would say that just give it a try as a sidecar, or just give it a try as a daemon set. But there's not like a strict rule for that. I think we have time for the last question. Oh, we don't have more time. So thank you so much, and thanks for coming.